Hello everyone, I am Vaishali Fulari. Welcome back to my channel pvaishalismathematicsclasses. We are studying a 9th standard chapter from the CBSE board. The chapter name is the Polynomials and this is the second chapter from your book. Let us discuss about the factor theorem. If p of x is a polynomial, as in introduction part only we discussed that any polynomial can be denoted with the p of x of degree n is greater than or equals to 1. What is mean by degree? The highest power of that polynomial, right? Next, here what should be the degree? It should be minimum, it should be 1 and maximum it is up to the n, means you can take the any value, but it is here we are not taking any zero polynomial or the constant polynomial. The minimum degree should be the 1, means we are taking the linear polynomials, and we can take the degree of this polynomial, it can be anything, and a is any real number. Then what is this a? Here it is given that here a is any real number, then x minus a is a factor of the p of x. When we say x minus a is the factor of this polynomial p of x, if p of a is equals to 0, which means that this is our polynomial p of x. First of all, x minus a we are equating it to the 0. By this what we can get? X is equals to 0 plus a, which means x is equals to a. Wherever x is there, we are substituting the value with the a. Then after substituting this a, if we get the 0, then we can say that x minus a is the factor of this polynomial p of x. And the second condition, suppose if p of a is the 0, p of a is equals to 0, then we can say that if x minus a is a factor of the p of x, in that case x minus, if p of a, if it is becoming the 0, then what can we say? If x minus a is the factor of this, means let us take the example. This is our polynomial x plus 1. If we take p of minus 1, then minus 1 plus 1 is equals to 0, which means p of a, means here instead of the a, what have we taken? Minus 1. If this is the factor of this, we are getting the 0, or vice versa. If this is the 0, means x plus 1 is the factor. Then how can we get this minus 1? First of all, this x plus 1, we should equate it to the 0. Then x is equals to minus 1. Then we are going to substitute the value of this x is equals to minus 1 in the polynomial, so that we can get the 0. Finally, what can we say? If p of a is the 0, then it is the factor of x minus a. And if it is a factor of the x minus a, then p of a is the 0. Both the things are correlated. Let's discuss about the 2.3 exercise. The question number 1 is, determine which of the following polynomials has x plus 1 a factor. Here we have to determine whether this x plus 1 is a factor of this given polynomial or not. First, this is the given question, x cube plus x square plus x plus 1. First of all, let us take this polynomial as the p of x. Let p of x is equals to x cube plus x square plus x plus 1. If x plus 1 is a factor, then we should equate it to the 0, so that we can get the value of the x is equals to minus 1. Now put x is equals to minus 1 in p of x. Then what it become p of minus 1 equals to, wherever x is there, we have to put the minus 1. Minus 1 whole cube plus minus 1 whole square plus minus 1 plus 1. Minus 1 whole cube is the minus 1. If there is the base minus 1 and the power is in the odd numbers, always we get the minus 1. And if the power is the even number, we get the plus, means positive number, that is plus 1. Plus minus 1 into minus 1 is the 1. Plus into minus, minus 1 plus 1. Here minus 1 plus 1, minus 1 plus 1. All will become 0. Finally, we will get the 0. As we are getting the 0 of this, means x plus 1 is the factor. If we don't get the 0, x plus 1 is not the factor of the given polynomial. Like this, we have to declare the answer. Therefore, x plus 1 is a factor of x cube plus x square plus x plus 1. The second bit is given as x to the power 4 plus x cube plus x square plus x plus 1. I will write what the polynomial is given to us, plus x square plus x plus 1. This is the given polynomial. First of all, let p of x is equals to, as our polynomial is in terms of deck, that's why we are denoting p of x here. X power 4 plus x cube plus x square plus x plus 1. Next, it is a factor. If this is a factor, then p of a should be 0. First, we will get the value of the x by equating this x plus 1 equals to the 0. X is equals to minus 1. Put x is equals to minus 1 in p of x. If you put x is equals to minus 1, p of minus 1 equals to minus 1 whole power 4 plus minus 1 whole cube plus minus 1 whole square plus minus 1 plus 1. Minus 1 whole power 4 means it is the even number, we get the plus 1. Minus 1 whole power 3, it is an odd number, means power is the odd number, that's why we will get the minus 1. Minus 1 whole square is the plus 1. Minus 1 plus 1. Plus 1 minus 1 plus 1 minus 1. These 4 will get cancelled. What is remain? Only 1. Means we haven't got the 0. Means p of minus 1 is not equals to the 0. We got the 1. That's why x plus 1 is not a factor. Therefore, x plus 1 is not a factor of p of x, or you can write the polynomial here. The third bit is given as x to the power 4 plus 3x cube plus 3x square plus x plus 1. 3x cube plus 3x square plus x plus 1. This is the given polynomial. Let p of x be x power 4. I am writing the same here. Is given x plus 1 is a factor, that's why it should be equated to the 0. X is equals to minus 1. Put x is equals to minus 1 in p of x. P of minus 1 equals to minus 1 whole power 4 plus 3 into minus 1 whole cube plus 3 into minus 1 whole square plus x minus 1 plus 1, which implies minus 1 whole power 4 gives us plus 1. 3 into minus 1 whole power 3 is the minus 1. Minus into plus will be minus. 3 into 1 is the 3. Minus 1 whole square is the plus 1. 3 into 1 is the 3. We get plus 3. Next minus 1 plus 1. Here plus 1 minus 1 will get cancelled. Minus 3 and plus 3. 1 is remain. Here also we haven't got p of minus 1 is equals to 0. P of minus 1 is not equals to 0. Then x plus 1 is not a factor of x power 4 plus 3x cube plus 3x square plus x plus 1. In this way, we can write the conclusion. The fourth bit is given as x cube minus x square minus 2 plus root 2 into x plus root 2. Let us take p of x is equals to x cube minus x square minus 2 plus root 2x plus root 2. X plus 1 is equals to 0. X is equals to minus 1. Again, we have to follow all these steps in every question. Put x is equals to every question from this bit minus 1 in p of x. So what will happen? P of wherever x is there, just substitute minus 1. So p of x means p of minus 1. Here is the x cube minus 1 whole cube minus 1 whole square minus 2 plus root 2 into minus 1 plus root 2. Minus 1 whole cube is the minus 1. Minus 1 whole square is the plus 1, but outside there is minus 1. Minus is that, that's why minus 1 will get. Next, minus into minus is the plus. So 2 into 1 is the 2, root 2 into 1 is the root 2. So simply we can write plus 2 plus root 2 plus root 2. Minus 1 is the minus 2 plus 2 plus root 2 plus root 2. Minus 2 plus 2 will get cancelled. Root 2 plus root 2 is the 2 root 2. So what we got, p of minus 1 is not equals to the 0. So that's why x plus 1 is not a factor of x cube minus x square minus 2 plus root 2 into x plus root 2. From this 2.3 exercise, let's move towards the question number 2. The question number 2 is, use the factor theorem to determine whether g of x is a factor of p of x in each of the following cases. Here, two polynomials are given to us. One is the p of x and second is the g of x. And here we are asked, use the factor theorem. Just now, we discussed the factor theorem. What this factor theorem is telling to us? The factor theorem says that p of x is any polynomial of degree n where n is greater than or equals to 1. Means we are taking the polynomial's degree as 1 or more than that. Next, and a is any real number. A is any real number. Then the first case is given as x minus a is a factor of p of x when P of A is equals to 0. Whenever P of A will become the 0, we can say that the x minus A is the factor of this P of x. And the second case, if P of A is equals to 0, then x minus A is the factor of this P of x, right? So here instead of x minus A, what they have given? The g of x. Means don't confuse here. This is nothing but a polynomial. If we get the 0, then you can say that g of x is a factor of the p of x. If we don't get the 0, g of x is not a factor of this p of x. In that, first bit is given as p of x is equals to 2x cube plus x square minus 2x minus 1 and g of x is equals to x plus 1. First we write the given data. P of x equals to 2x cube plus x square minus 2x minus 1 and g of x is equals to x plus 1. We have to determine whether this g of x is the factor of this or not. For that, we have to equate this x plus 1. It should be equals to the 0. X is equals to minus 1. Put x is equals to minus 1 in P of x. P of minus 1 equals to 2 into minus 1 whole cube plus minus 1 whole square minus 2 into minus 1 minus 1. 2 into minus 1 whole cube is the minus 1. 2 into minus 1. Minus 1 whole square is the plus 1. Minus into minus is the plus 2 minus 1. Plus 1 minus 1 will get cancelled. 2 into minus 1 is the minus 2 plus 2. Here also we get the 0. As we got the 0, we can say that g of x is a factor of p of x. Next, question number 2 from this bit. P of x is equals to x cube plus 3x square plus 3x plus 1 and g of x is given as the x plus 2. I am going to write the given polynomials. First of all, P of x is equals to x cube plus 3x square plus 3x plus 1 and g of x is given as x plus 2. First, as we have to determine whether the g of x is the factor or not. For that, we have to equate this g of x is equals to the 0. What is the g of x? X plus 2, which is equals to 0. X is equals to minus 2. Why we should equate it to the 0? If it is a factor, means it should be equals to the 0. That's why we are equating here. X is equals to minus 2. Put x is equals to minus 2 in P of x. What is the P of x? P of x is this one. So we have to substitute with the minus 2 here. Minus 2 whole cube plus 3 into minus 2 whole square plus 3 into minus 2 plus 1. Minus 2 whole cube is the minus 8. 2 2 is 4, 4 2 is 8. Minus power odd number, that's why we will get the minus number. Plus minus 2 whole square is the plus 4. 4 3 is 12. 3 into minus 2 is minus 6 plus 1. Minus 8 minus 6 is minus 14. 12 plus 1 is the 13. Minus 14 plus 13 is the minus 1. So what we got? P of minus 2 is not equals to the 0. So as we haven't got the 0 here, that's why g of x is not a factor of the p of x. G of x is not a factor of p of x. Third bit is given as p of x is equals to this and g of x is equals to x minus 3. Let us write this. P of x equals to x cube minus 4x square plus x plus 6 and g of x equals to x minus 3. As g of x, whether this g of x is the factor or not, first of all we have to equate this g of x to the 0. So what is this g of x? X minus 3, which is equals to 0. So we can get x is equals to 3. Put x is equals to 3 in p of x. So p of 3 equals to 3 cube minus 4 into 3 square plus 3 plus 6. 3 cube is 27 minus 3 square is the 9. 9 4 ja 36 plus 6 plus 3 is the 9. 27 plus 9 is 36 minus 36 plus 36 and minus 36 we get the 0. As by substituting p of 3 we got the 0. Therefore what can we write? G of x is a factor of the p of x. In this way, we solved the question number 1 and 2 from this exercise 2.3. Please keep watching to my channel. We are going to complete this exercise in the next video. Thank you.